Okay, well, how do we do the very first one? Well, then tell me. How would you go about solving the first one? Yeah, distribute the 2. Distribute the 2, so that's 2 minus 2x equals. Distribute the 3, so that's 3 plus 6x plus 5. Is that okay so far? What do we do next? Combine like terms. 2 minus 2x equals 8 plus 6x. Is that okay? Now what? All right, subtract 8. Okay, subtract 8, then add 2x. Is that okay? So you have negative 6 equals 8x. So divide both sides by 8. X equals negative 6 over 8, which is 3/4. Good? Well, it's there. All right, what about this one? Distribute the 4, so you get 4y. What is 4 times a half? So minus 2 minus y, I'm losing a y here, equals 30 minus 6y. Is that right? Combine like terms. 3y minus 2 equals 30 minus 6y. Is that right? Now what? Add the 2 to 30, add 6y to 3y. Is that okay? So it gives you 9y equals 32. Is that okay? So what is y? 32 over 9. Is that right? Which is 3 and 5. So, I mean, you can get away with it. The bigger problem if you don't reduce your fractions. Like, if you let your answer is 6 over 8 in the previous one, instead of reducing it to 3/4. But this one is, I don't know what the big deal is. But, technically, yeah. That's a mixed fraction. That's an improper fraction. Is that right? Is that what you got? Yeah. It was just random one. That's what. Okay, now the moneymaker. But what did I tell you? If you hate that one, you hate it because of what? Color blue, or there's a reason why you hate it? Because it's white? No, no, that's not what you hate. All the fractions, right? That's why you hate it. But what did I tell you? If you have all the fractions, what should you do? Which is what? 12, right? For everything is 12. So multiply both sides by 12. That will help you to get rid of all the nasty little fractions. Because if you do that, life is going to be good, right? Did you try that? So let's take immediate step. 12 times 2/3 y plus 12 times 1/2 y minus 3, right? You distribute 12 through. On the other side, how many times 4 goes into 12? 3. So this is 3 times y plus 1. So here, what is 2 times 2/3? I'm sorry, 12 times 2/3. Right. 3 goes into 12 4 times. 4 times 2 is 8, so 8y. Right? 2 and 12, how many times 2 goes into 12? So it becomes 6 plus 6 times y minus 3. Yeah. That one? Nothing. It's still there. I haven't written it yet. I didn't do anything with that one. You mean that one? Yeah, it's still there. So it's equal 3 times y plus 1. It's still there. Right? So now we don't have any fractions. So we can, that's why I gave you, didn't even pull out the, have you seen me doing the clock thing yet? No? Haven't? That thing? Yeah, the clock? Yeah, I did it once, right? Oh, yeah. Okay, go away. I don't know how to get rid of it now. Well, I can go back in time. That's the, right. Come on, get out of here. All right, now it's a simple problem. No fractions. 8y plus 6y minus 18 equals 3y plus 3. Right? 14y minus 18 equals 3y plus 3. Subtract 3y, subtract 3y, add 18, right? What does it look like? 11y equals 21. So y equals 21 over 11, or 1 and 10, 11. Is that what you got? Good. Good. So when you have fractions, kill them. You got the killing part right? Good. That's not good. Huh? Well, anyways, we spent first, what, is it week 5? Do you know this is week 5 already? Isn't that crazy? That means quarter of a semester is behind us.
So week 4 is 2.
Yeah, homework 4 is, yeah. So it's week, but at the end of this week, so it's a third of the semester. Wow, that's fast. Anywho, but we did nothing but linear equations. And we've seen 3 cases. Most of the time you get one solution. Sometimes you get no solution. Sometimes you get all solutions, all real solutions. But when you get a thing like that, one real solution, just one point, right? Just one. Do you know where that thing lives? No, not under the bridge. So nothing wrong with that number. Not saying that living under the bridge is somehow wrong, but it's definitely frowned upon. So somewhere here, wouldn't you agree? 1 and no, actually you should disagree. It's actually closer to 2 than 1, right? Somewhere there, right? We can graph our solutions because our solution is just one real number. I can plot that number on the number line. Okay? Are you with me on that? So that's what happens when you have a linear equation with one variable. Sometimes we have linear equations with, or just equations with more than one variable. Okay? So we can look at equations with 2 variables. Okay? So for example, I can have this equation, y equals 2x squared plus 1. So this is an equation with 2 unknowns, x and y, and I should still try and solve that equation. Now, we haven't seen equations like that. Now, how many solutions do you think it will have? Because I need to have an x value that corresponds to a y value. So can you... No, not really. No, that thing is squared, so it's... Yeah, that's different. But basically, I'm asking you for the value for x and the value for y that make that equation balance. Can you give me an example? X and y value that if I plug those in, something for x, something for y, it makes that equation balance. So for example, x equals 7, y equals 11. If I plug them in, does that work? Probably not. But I want you to find the two values that do work. It is easier than you think. Do you understand what I'm asking you? Doesn't have to be. I'm just asking you to give a value to x and to give value to y, so that equation balances. 0 what? 2 zeros? Yeah, that's probably not going to work. And y equals 33? Yeah, right? So here's a suggestion. Let x equal 4 and let y equals 33. That's what you just told me. Well, I tried to push you because it definitely works if y equals 33 and doesn't work with anything else really. But so here's an example. If x equals 4 and y equals 33, if I substitute these two values, will that work? If I plug 33 for y and I plug 4 for x, does that work? Is 33 the same as 2 times 16 plus 1? Yeah, looks like 33 equals 33. So yes, this right here is a solution to that equation. X equals 4, y equals 33. Well, okay, give me an example. Y equals 9. Does that work? We're just really trialing and erroring that thing. But really what you're doing, you just toss the value for x, and it just gave you the value for y. But yes, that works. If I plug in 2 for x and 9 for y, that balances. How many more of this can I find? A lot? A bunch? Yeah. But I have to be a little more careful. I mean, I cannot just randomly throw in values, right? I cannot just write any two random values and say they work. They don't. But there is a specific relation between x and y that's actually defined by this equation. But really, you can throw in any value for x. X equals -3. And you can figure out the value for y that satisfies that equation, right? What would that be in this case? What is -3 squared? 9, right? Because x is squared, so -3 is squared, so it becomes +9 times 2 plus 1, 19. So looks like that's going to work. So I just found 3 solutions to that equation, right? And I can keep going and going and going. Will I be able to ever list all of them? No. Okay? That's impossible to list all solutions to that equation. The only way that I can show that solution, the only way that I can represent all the pairs that solve this equation is by kind of doing this, graphing them. That's the only way I can represent all the solutions to that equation is by graphing. And that's what graphs are. All the graphs that you've seen before, not in this class, we haven't done any graphing yet, but you've done graphing before, right? I mean, you've done the pretty little curves. All of those are solutions to equations with two variables because there's no other way to represent the solution. So, but unlike in the previous example where we only had one variable, I need two variables, so I need two number lines. So we take one number line and we cross it with another number line. These are two number lines, and we just like to call the horizontal line as x and the vertical line as y. Just historical, okay? And now the way we label it, the point where the lines intersect, that's called the origin. The location of the origin is 0, 0. And that's what we actually do. This is full of ordered pairs, okay? What we have on this, now we call a plane. This is the coordinate plane. Sometimes it's called Cartesian plane. Not 100% how to spell that, so I'm just going to scribble. It consists of an infinite set of what we call ordered pairs. And the ordered pair is something like that, where the x is the first number and the y is the second number. Okay? So, like here, when I have -3 for x and +19 for y, I have something like that. This is the ordered pair. Now it's located over here. This is +1, this is +1. So this is -1, -2, -3 on the x, and 19 on the y, whatever. So -3, 19. That's where that number is. That's where that point is. And if I continue plotting all those points, what was the other one? 2 and a 9. So 2 and a 9. The other one was 4 and 33, so I'm off the grid. Okay, but what I can do, I can generate a table of values in order to grab this equation. X and y values, and the equation is y equals 2x squared plus 1. And you can choose anything you like for the x. And traditionally, we pick few negative numbers, we pick 0, and we'll pick few positive numbers. So that's usually enough to get an idea where the graph is going to go. And now we're going to take each one of those points, each one of those x values, substitute it for x in our equation, and find the y value. How many of you done that, by the way? Yeah, all right. But anyways, so -3 squared is 9 times 2 is 18 plus 1 is 19. -2, so we got 9, -1, you get 3, 0, you get 1, and then you'll get the same values. I mean, you can double check. Do you understand how I'm getting the y values? Just plug those in. So if I plot those points, so here's -2, +9, -1, 3, 0, 1, 1, 3. So I'll end up with something like that if I connect those points. Okay? Is that okay? So what that means, every point along this curve, every point on that curve solves that equation. And this is the only way we can express the solution to that equation, is by, well, graphing all those possible solutions. There's no way I can list them. That's impossible. Sure? Yeah, that's a parabola. We don't need to know that, but sure. But basically, all that says that if I grab this point right here, it doesn't solve that equation. This point, whatever this is. It's not going to work. While if I take this point that's on the graph, it will work with that equation. It will satisfy that equation. Does that make sense?
Can you remind me why you started it?
Just because I can. Yeah, we call x as the independent variable and y is dependent variable. So I randomly pick values for x, and then I plug them into my equation to get the values for y. So y depends on x. But I just chose whatever I wanted for x. And usually you pick few negatives, few positives, and 0. If allowed, because there are some equations where you cannot plug in negative x's. There are some equations where you cannot plug 0. Yeah, so, if you have division by 0 or some kind of a square root somewhere. But usually that works. Few negatives, few positives, 0. And then you get a pattern. So unless your points are on the same line, we connect them with some kind of a smooth, curvy line. Okay? By the way, smooth is a mathematical term. We describe graphs as smooth. Okay? That's true, not making that up. There is a definition of smooth in the math textbooks somewhere. Is that good? So, okay. So coordinate plane or Cartesian plane, whatever you like. Now, if I go back to the number line, I can also identify the intervals on the number line. So here's the phrase. All real numbers greater than 2. Okay? No. Oh, we don't need to worry about that. We'll just assume that real numbers, but mostly I'm worrying about the greater than 2 part. Okay, so basically x will represent real numbers, and every real number that we talk about right now should be greater than 2. That's the notation for greater than 2. Are you okay with that? So we know the greater or greater than or equal to notations. But how would I graph this? All x is greater than 2 on the number line, provided that this is 0. So I'll pick 2, right? And do I go to the right of 2, to the left of 2? To the right, right? That's the greater part. Now, and this is the important thing, is 2 part of that set? I'm saying greater than 2. So 2 itself, right. So greater than 2 does not include 2. So the notation for that is an empty little circle at 2. So this is how we'll label on the graph that 2 is not included. We're kind of putting an empty circle. So this would be the graph. Everything greater than 2. Now the interval notation for that would be, well, everything from 2 to infinity. Now we use a parenthesis next to 2, so parenthesis, I don't know, parenthesis. How do you do parenthesis when it's just 1? How do you spell that? Y or? Yeah, no, this is confusing. I've never really encountered word parenthesis it's usually parenthesis. Yeah, 1. Parenthesis 1, just that one. You always have a parenthesis around infinity. But when we do the interval notation, the parenthesis represents that, yeah, so you, yeah, we'll pass that. I don't care anymore. So the parenthesis in the interval notation means that we do not include that point. So when you see that notation with a parenthesis around 2, that means 2 is not part of that set. Now, if 2 was a part of that set, we have those little brackets. Okay? Now, this is probably going to confuse you all, because the notation is very similar to the ordered pairs that I just introduced. We have to understand that, even though notation is the same, the things are not the same. This is an ordered pair, just a point on the plane, while this is an interval on the number line. So don't confuse the two. And it's very hard to confuse the two because you really know whether you're talking about a point or an interval. But anyway, so parentheses means do not include, or not part of the set. So does that make sense, how to graph it? So here's the English, here's the math, here's the interval, here's the graph of the same kind of phrase. Okay? I'm going to give you another. All real numbers that are greater than or equal to -1 and less than 2. So here's the English phrase. All real numbers that are greater than or equal to -1 and less than 2. Can we graph that? So which two numbers are important here? So here's -1 and here's 2, right? So everything greater than -1, so to the right of -1, but to the left of +2, right? Now, since we include -1, right, because it's greater than or equal to -1, the proper notation is that kind of a filled-in circle. That means we include that point. 2 is not part of that set, so we use an empty circle like that. So that will be the graph of that interval. So now, mathematically speaking, you have all the x's that are greater than or equal to -1, but less than 2. So you can write it like that. So every number on that interval satisfies that inequality. And on the interval notation, it is from -1 to 2. We put a bracket around -1 and a parenthesis around 2. So the bracket means we include something that's part of the set. Parenthesis means it's not. So every time you have a less than or greater than or equal to, that equal part, you have a bracket next to it, you have a filled-in dot. Every time it's strict inequality, less than, greater than, without the equal part, you have an empty circle and a parenthesis. Okay, so parenthesis means do not include, brackets mean do include. Always parenthesis around infinity because we cannot include that. Okay? Well, I've seen brackets around infinity, so we need to, make sure we understand that. Because otherwise, that means you just stop somewhere and we cannot. How about all real numbers less than or equal to 3? So I want us to write it mathematically. So x something. I want us to graph it. And I want us to do the interval notation. Let's graph it first. How would you graph it? All right, so circle, kind of filling in the circle at 3. Left or right? Left. So everything less. How would you write it with relationship to x? So x would be the number that satisfies that sentence. Like that, right? X is less than or equal to 3. Right? How about the interval? So what's on this side? Yeah, so it's negative infinity with a parenthesis, comma, 3, bracket. So we always start with the smaller to the bigger. So whatever it is to the left, go ahead. That's the negative infinity. So it's infinity sign with a minus in front of it. So we're starting all the way to the left. Well, it's just, negative infinity. To the right, you have positive infinity. So we go from negative infinity all the way to 3. We stop at 3 and we include 3. So the bracket means including. Parenthesis means excluding. All right, good. So we're kind of getting into graphing. So I do have a little worksheet for you. And there's a question 5 that you definitely should not be attempting because it's not finished. No, you don't know. It's just